this unit is if you have something like this, how would you solve that problem? Okay? Yeah, like it's a log. Yeah, so like ones we were doing yesterday, why I stopped for a second, I wanted to do exactly what the quiz was on yesterday. So if you had something like the quiz from yesterday, it would look something like that. Tell like there was a 2 over here, and then you have this raised to the t. And like, how would you solve that then? That's going to be the goal moving like in this unit on how to, what the purpose of logs are. Specifically, whenever you have your variable in the exponent, that's when you would use something with logs. Because in logs, it's equal to the exponent. If it's equal to the exponent, then that is by itself on one side of the equation, and everything else is on the other side. Does that make sense, you guys? Like, for example, in this case, how would you rewrite this in log form? What would you do? Log, here's your base. What goes here? 2 equals t. So you just solved for t. Do you know what I'm saying? You just got it all by itself. Do you see how that works, Anna? And now what would be the next step if, because I can't put this into my calculator like this, what would I do next? I don't know, I can't. Not divide, what's that rule called? You can change and base it. Log this divided by log, and this is base 10, log 1.05. Or natural log 2 over natural log 1.05. And then you can solve that problem. Does that make sense, you guys? You can solve exactly for when that happens. Another way to do it is, what you're going to be doing a lot this year, is you know how you can square both sides and square root both sides and everything like that, Michelle? Well, if your goal is to say this is equal to this, well then wouldn't it also be true that the natural log of this would equal the natural log of this? Does that make sense, you guys? And that's the same thing with like if you have 2 sides of an equation, you can square root both sides. Because if you want those equal, then their square roots must also be equal. Does that make sense, Chris? So you can also natural log both sides. Because if you want this equal to this, then the natural log of this has to equal the natural log of that. Well, using one of those rules from yesterday, what you can do is, you have a log with something raised to the exponent, you can bring the exponent down. So this is the same as natural log of 2 equals t times natural log of 1.05. Do you remember that rule from yesterday? Or being aware? That's one of the rules. And now this is a number, and this is a number, so you can divide both sides by this to get t by itself. Okay? Yes or no? Does that make you happier said, hey, was that a good or bad laugh? It is good. It's another way to look at the problem. What we're going to be doing a lot is problems like this, when you got like 8 equals, like, so did anyone wonder why I did natural log both sides? It doesn't matter which log you do. You know what I'm saying? Like, for example, another log that I would like to do in this case would be log base 1.05, 2 equals log base 1.05, 1.05 t. Why would I choose base 1.05 in this case? This is that rule. This is one of the rules. If you have log this base to this, then that has to equal 1. Or, I'm sorry, this whole thing is equal to t. So this is the same as log base 1.052 equals t. Now we're back to here. And then you do change of base to solve it. There's another way to look at how to solve the same problem. And what we're going to do a lot this year is something like this. 8 equals e to the 2x. If I natural log both sides, you get natural log of 8 is equal to natural log of e to the 2x. And natural log is log base e. So since this is log base e to the 2x, what's this right side equal to? 2x. So now you have natural log of 8 is equal to 2x, and then you can just solve for x. Questions? This, and this are three different ways to solve the same problem using different log rules. The goal, the only goal in a log rule, is to solve for this variable. And in logs, it's equal to the exponent. You could also graph this, and solve for the intersection point. All of those are valid ways to solve this problem. And then here's just another side example. Okay? That's the takeaways from logs. That's what you're going to be doing a lot as the year goes on. Just solving for this variable. So you're going to have to do some sort of log thing to get it down, to get it out of the variable. To get it out of the exponent. Okay? Alright. Any other questions on logs? Again, if you're having trouble before or after school, do not hide from it. It's just practice, just like anything else. You have to put in the practice. Okay? Alright, 1.6 notes. So 1.6 is all about trig. Now we got today to talk about it. Tomorrow is our review day. So tomorrow we can talk about anything you want. We can spend the whole day talking about trig if you want, whatever you want. And the test is on Thursday, 1.1 to 1.6. The summer packet is also due Thursday. So if that's already done, great. One less thing to worry about. If it's not, you got a lot of work on your hands this week. I'll see you before or after school. Okay? And then you have trig boot camp going on in the morning. And again, I'm probably going to cover 7-8 days of morning stuff in one. We're going to go through it very quickly. So if you're struggling with the trig stuff, let's just work on it before or after school. Okay? All right. So the first thing we're talking about is radian measure. Everything you're going to do in calculus is in radians, not degrees. So here's what a radian measure is. If I have a circle, and I draw a radius in of any length, let's call it length 3. That looks like 3 units of length. And I take this same length here, and I put it along the arc of the circle, the same length. So whatever the radius is, again, with circles, whatever it is, the circle is just going to get bigger as this gets bigger. So it's going to go to here. I take that same length 3, and I measure it out on the arc. And then if I, from this point, take another radius and connect it back with the center, you've just created an angle measure of 1 radian. That's how 1 radian is defined. It's actually this ratio of sides. And it works for any circle. This could be 2, it could be r, it could be 17. You take this length, you measure it here, and you come down, and that is 1 radian length. Okay?